Okay, so just to recap what we did the other day. Sorry, it's 4.2. Lesson 4.2 was completing the square, okay, which is turning standard to vertex form. So we're in standard form right now, and we had to complete the square, which is a process to turn it into vertex form. The first thing we need to do is I need to make sure that our x squared has a coefficient of just 1. So what I'm going to be doing is I am going to divide the first two terms by the coefficient in front of x, whatever that number is. So because the number is 2, we divide the first two terms by the number 2. You can, it just becomes a fraction. So when we divide it by 2, we're left with x squared plus 6x plus 19. Okay? Now that we've done that, what's important is our b value, which used to be 12x, is now 6x, or the number 6. The formula I need you guys to remember is we take b divided by 2 and we square it. So since b is 6 in this formula, okay, we put 6 in divided by 2, which will give us 3. 3 squared is the number 9. This number 9 is very important because we're going to add and subtract the number 9 inside the brackets. So what happens in the next line is we take 2x squared plus 6x, and I'm going to add 9 and subtract 9 inside the brackets, plus 19. The reason this works is because adding and subtracting 9 is like adding 0. They both cancel each other out. But the point is we're trying to complete a perfect square trinomial. We're trying to make one. Okay? So I then take my negative number, which is negative 9, and I got to take it to the outside of the equation. In order to do that, I have to multiply it by the term in front of the brackets. So that number 2. So when I take 9 to the outside, it has to be multiplied by the number 2. Whatever was in front of the brackets. It happens to be 2 in this case. We get 2 times x squared plus 6x plus 9 stays down. The negative 9 times 2 becomes negative 18 outside the brackets plus 19. Okay? We're going to simplify the constant numbers on the outside, and it'll be plus 1. So what's important next? Okay, so what's very important is what I've created is a perfect square trinomial, which means I can square root the first and the last term inside the brackets. So the reason we're finding the square roots of those numbers is they're going to go into one bracket. The square root of x squared, the square root of x squared is going to be just x, and the square root of 9 is going to be 3. So we take the x, it is our first term. Our second term in the brackets will be 3. And whatever sign is in front of our b comes down. So we get positive, we get x plus 3. I then put a squared outside the brackets and plus 1, and we're now in vertex form. Now what I did to these brackets is I factored it. I knew this would work for factoring, square rooting the first and last term. If you rather use one of our old methods of factoring like decomposition or by products, that's fine, but this is the fastest way. We know this will work because we created a perfect square trinomial. The perfect square trinomial, the reason this works is because I squared the b term, okay? So because I squared the b term, I created a number that I can find the square root of, okay? So it'll always have a square root. It'll be the one that works. The whole point of this is we're creating this. if you guys notice, we started with these brackets, and then we added the number 9. We took the negative 1 out. This is a perfect square trinomial. The whole reason we did all of these steps was to create this bracket so that I could find the square root of the first and the last term, and I knew that it would be x plus 3 squared. That would be the factored part of this. We created that. Our next example, we look at our a term, or the term in front of our x squared. I actually have a fraction. So remember, I'm trying to create a 1 in front of the x squared. Technically, what number would I divide by? Okay, I would divide by a half. These first two terms, I would divide them both by a half. But dividing by a half is a confusing process. Yes. Okay. If we have a fraction in front, the same idea is we just multiply both of the terms by 2. Sorry. I'm not sure why I left out the fraction in that. Fraction's a part of this. Okay. 1 over 2. In order to move a half outside the brackets, and remember, I'm going to end up with a half outside of the brackets, it's the same process as multiplying by 2, and I'll quickly show that over here. So if we have a half x divided by 2, okay, I technically have fractions here. So I wanted to turn this into a fraction, which becomes 2 over 1. And with our fraction rules, when we're dividing fractions, we change it to a multiplication question, and we flip the second fraction. Okay? Oh, sorry, I'm dividing by a half, not by 2. I was wondering why that came out funny. So we're dividing by a half. I need to flip the fraction and change it to a multiplication question. So I get times 2 over 1, which is the same as multiplying by 2. So I'm going to get 2 over 2x, which is essentially just 1x. So the idea here is if you divide by a fraction or divide by a half, it's the same as multiplying each by 2. So what I'm going to be doing is I'm actually multiplying both of these terms by the number 2 instead of the dividing we were talking about. So what we did is we found the common factor, or well, not a common factor. We took the half out. We divide both of these by a half, which is the exact same as multiplying by 2. Okay? Normally we're dividing by whatever term's in front. So what I'm left with is x squared. And when I take 3 divided by a half, think of it like 3 divided by 0.5. So 3 divide 0.5 gets us 6, which is the same idea as 3 times 2. Okay, that's what I was trying to show you, a shortcut. So we get 6x in there plus 4. So what I did, again, I divided each of these by a half. If we had, I'll show you the half, brackets 1 divided by 2, end bracket, divided by 1 divided by 2, we end up with the number 1. Okay, and that was the whole idea. We were trying to create 1x squared, just like we did in the other one. So I know because it was a fraction, it was a little more confusing. Now that we've done that, we go right back to our little formula that we have written up here. We know we have to have b divided by 2 squared. It just so happens in the same question that b happens to be 6 again. Okay, so we type, when we plug in 6, it's 6 divided by 2 squared, which is 3 squared, which is 9. So I need to add and subtract the number 9 to those brackets. So we have a half x squared plus 6x plus 9 minus 9 plus 4. So I added and subtracted 9 inside the brackets. Now remember, this 9 has to go outside the brackets. So what do I have to multiply when I put it outside the brackets? By a half, or 1.5. No, it's not 2 every time. In this case, it's a half. So we're multiplying by a half. So now that we've done that, we have a half x squared plus 6x plus 9 Negative 9 times a half, or 0.5. So we have negative 9 times 0.5, negative 4.5. So we get negative 4.5. Okay, so when we took the 9 out and we multiplied it by a half, we got negative 4.5. Now what's important here is, again, I'm left with a perfect square trinomial, so I can square root the first and the last term. I get a half, and in the bracket, the square root of x squared is just x. The square root of 9 is 3. We take down the middle operation, which is a positive sign, and I put a squared on the outside. And I equate the back, which will give us negative or negative a half. So this is it. This is our vertex form. 6 in the middle disappears.